Welcome back to the Flex Diet Podcast. I'm your host, Dr. Mike T. Nelson. And on this podcast, we talk about all things to increase muscle strength and improve body composition, all without destroying your health in the process within a flexible framework. Today on the podcast, super excited to have Dr. Jorn Trommelin talking about his brand new study that was published from his lab with Dr. Luc Van Loon and a bunch of other co-authors about 100-gram dosing of protein. What were some of the very cool effects that they saw? I'm super stoked to have him on the podcast so we can dig into all of the details there. I wanted to let you know that you can get his top 4 thoughts and actions about protein. You can get that exclusively at miketnelson.com/flex4. That's miketnelson.com/FLEX and the number 4. So you'll be able to get that as an exclusive for being on the newsletter, on the insider list there. If you're already on the newsletter, then you will be able to get this delivered directly to your inbox. So that little expert there will only be available at miketnelson.com/flex4. However, you'll be able to listen to the entire rest of the podcast here. Also wanted to let you know that the Flex Diet Virtual Metabolism Summit is coming up very soon. It's going to be February 9th through the 11th, 2024. We'll have a link for this below too. It's www.flexdietsummit.com. So I am organizing this, and I brought together over 30 of my favorite people from the industry as a collection of coaches, trainers, researchers, all talking about different aspects of metabolism and how you can use that to add muscle, increase your performance, and improve your body composition. Everyone from Ali Gilbert, Luke Lehman from Muscle Nerds, Rick Collins, Lee Boyce, Andrew Coates, Dr. Lonnie Lowry, Dr. Sue Kleiner, Dr. Lisa Lewis, Tony Gentilcore, and 30 plus other people. It's free to sign up. The weekend of February 9th through the 11th, you will be able to get access to all of the talks for free. We will have an upsell there if you do want to buy them to download, but you don't necessarily have to. Just go to flexdietsummit.com, opt in there, and you will be able to see all the talks for free coming up February 9th through the 11th, 2024. And last one here, my favorite electrolyte is from LMNT. So I've been drinking at least 2 of these for many years now. And what I've noticed is just overall my energy level feels better. It's just much more consistent. And the problem before was I just literally wasn't drinking enough water because I don't really like plain water all that much. Yeah, I could force myself to do it for a few days, but I didn't really stick with it. And what I also realized is if you're eating mostly real food, which is what I do most of the time when I'm at home, then I paradoxically wasn't getting enough sodium, which I know seems like a weird oxymoron, but getting more sodium and more electrolytes and having a lot more fluid, I just noticed a big difference in just total energy level was much, much more consistent one day to the next, especially since I'm going to be flying out to Canada for a ski and snowboard trip, which I'll probably be on by the time this is out. Having that on the plane makes a huge difference, I've noticed too. So if you're interested, you can get a free gift. Also, go to drinklmnt.com/Mike Nelson. drinklmnt.com/MikeNelson. So that is an affiliate link, so I do get paid a few bucks from them, but I love their product. I've been using it for many years, and it works really well. And if you don't like it, you can actually return it. They'll give you a full refund, no questions asked. So on to the podcast today with Dr. Jorn Trommelin, talking all about the 100-gram dosing study of protein. He is a researcher over in Dr. Luc Van Loon's lab in the Netherlands. He's published lots of great work looking at different aspects of protein, especially with overnight protein feedings and other studies. And he's a fitness bro, which is great. because he has very good ideas about what things should be tested. And he gives us a breakdown of this study. Should you be taking in 100 grams of protein? What are different markers for autophagy in this study that they measured? We talk about the building up of protein, or what's called the anabolic response or muscle protein synthesis, and then also the breakdown side of the equation. And shocker, what you've probably learned online about muscle protein breakdown most likely is not true. And we talk all about that. So enjoy this podcast with Dr. Jorn Trommelen. Back to the Flex Diet Podcast. I'm here today with Dr. Jorn Trommelen. How are you doing, sir?
I'm good. I'm good. Thanks for having me.
Yeah, thank you so much for doing this. I assume all is well. You're still in the Netherlands, is that correct?
Yep.
Beautiful weather there, or is it overcast this time of year?
So the
Yeah.
Netherlands usually is pretty rainy. It's not too bad right now, but it's you won't invite people here for the weather. Let's put it like that.
Yeah. Nice. And wanted to chat today about the cool study you did looking at 100 grams of protein. And before we get into that, like, how did you get into researching protein, and especially at the lab you're at there with Dr. Luc Van Loon?
The short version was I started very briefly at Maastricht University. Found out after 2 weeks, can probably do this, but is this fun? Only after seeing, do I really want to do this for the rest of my life? I started thinking about a career. I was like, okay, I'm always trying to read about fitness and nutrition. Let's do something with that. So start studying nutrition. Slowly started reading more and more stuff online, starting trying to understand studies. Like I remember the first time I read an abstract and I was like, what is this weirdly formatted text? But it sounds cool. Eventually found out that we had a pretty good lab in the Netherlands. Talked my way into there, and that's how everything got going.
No, that's awesome, because I know you've been into the fitness side and even the research side for quite a while. I remember reading some of your other articles you put out, and obviously you've done other research too. So what made you think that more on the protein side of, okay, I'm gonna, because the people, for listeners who are listening, like when you do a PhD, you have to pick sort of a skill set and a thing that you want to be known for, especially at first. And then maybe you can broaden out from there. A lot of people don't, but what kind of made you look at protein as one of the items?
Yeah, I was very lucky. So you mentioned Professor Van Loon, who is like probably the world champion in getting research funding. So I got to
Oh
try a
yeah. It's done
few
so many cool studies that are so expensive.
yeah, so I got to try a few things, a little bit of carbohydrate metabolism with more endurance, a little bit of resistance training and protein. And honestly, what I always liked the protein more because especially when I was younger, I was like more into let's build muscle, let's look good. But as I was doing the research, I remember that one of my first studies like got pretty heavily challenged by a reviewer. I was like, but because before I was like a simple bro, I just wanted to know how much protein, weigh your casein, give me the answer, move on.
Yeah,
But
yeah.
when with one of my first papers, I got pretty challenged by one of the reviewers, like on a very methodological, like how are these measurements working aspect. I was like, okay, I'll read into it. And pretty soon I figured out, I don't think this review understands how this works. And then I just started realizing, ooh, I think in our field, there's a lot of bros like me who just want whey versus casein. And there's very few people who actually understand the methodology. So I figured out my talent. It was just, yeah, it just came easy for me to do. Maybe it's because my background in the Maastricht University, that is what I gravitated for. So I saw that a lot of models that were used in the field were just suboptimal, started improving them, and therefore, yeah, could do cooler studies and new opportunities came up.
Yeah, and that's one thing I think people don't realize is that when you pick one area by definition, you don't do a lot of other stuff. Like I ended up looking at heart rate variability and metabolic flexibility when I moved to the exercise physiology department, literally because no one else in the entire department, even my advisor, understood any of the math. And so I did a master's in mechanical engineering, minor in mathematics. The math really wasn't too bad, but then you realize, oh, why would they understand it? They haven't taken any advanced math. It's just not part of the curriculum. So I think those kind of overlaps of areas, especially when you get into creating physiologic models and things of that nature, are interesting when you have the skill set to look at both sides.
Yeah, so two things come to mind. So the first one is, of course, you have to specialize. At the higher level you get, the more you have to specialize. Do you want your wedding photographer to be someone who says, oh, I shoot photos of babies, of weddings, of 12 things, or like all I do is make wedding photos? That person probably is better than the average random photographer. So it's the same with science. If all you've been doing is protein studies for the last 10 years, you probably have some good ideas of what to do next. But what I think, let's call it, the fitness people are pretty good at in general, because it's so practical. I feel that most people who have some overlap with nutrition and exercise, on average, they are pretty interested in other things. So it of course depends. Like, you have the truly hardcore scientists, but I think there are a lot of people who, for example, protein is their main field, but they know quite a bit of most macronutrients, most supplements, for example. But yeah, someone who claims who is the world expert at everything is probably nowhere near in any of that.
Yeah, there's a lot of, let's say, self-proclaimed experts online, and usually those are the hilarious ones where you'll put up some huge study and they'll have some just weird comment and not even like asking a question. It'll be like, oh, so for example, like some of the studies you did early on in Luc Van Loon's lab was looking at basically tracer labeled casein protein, looking at it for overnight sleep. And you talk to him and he's, yep. And we woke him up in the morning with muscle biopsies and just this whole intricate study that took forever to get done. And then you have all the bros online that are like, oh, they use casein because casein is this slow acting protein. And they did it as a practicality because you can only get the tracer into the casein, and the whey would be just ungodly expensive, which I think was actually done later. But so you see all these kind of criticisms of people who've never done research or even bothered to, hey, you could maybe ask the researcher, hey, why did you pick this? Because there's probably a pretty good reason they did it that way. And it's not because all of them are inept and don't know what they're doing either. That's my pet peeve.
There's two things. So some people, they like to dunk on studies and or researchers, because if they can show online that maybe they
Right.
have some small limitation, then clearly they must be smarter than the researcher. While in practice, the answer is like, I would love to do it, it's just not possible because of reason X. 9 out of 10 times reason X is more money.
Money, yep.
It's like, why didn't you add a third group who did this? Oh, I never thought of that.
Never entered my mind, man.
but at the same time, like, the natural tendency of people, oh, that's a cool study. Hey, if you would change this, what do you think would happen in that scenario?
Yeah.
That is super good. But it's all how they bring it. It's like, why did you do it like this? You should have done it. That is just horrible. But if they're like, hey, what do you think would have happened if you had a different type of protein? Would you expect the same, and why? That is just useful debate. So it's really a hit or miss depending on how they phrase it.
Yeah. And if anyone has ever done any research, and you just realize how long this stuff takes and how expensive it is. And even when I just studied energy drinks, people were like, exactly, why didn't you have a third group that was no caffeine or this, or why did you use this placebo? And one, it was time and money. And also, I'm trying to get these volunteers. I wasn't able to pay them anything. So they're already doing 4 max tests in the lab. If I had another group, that's a 5th max test. If they drop out with that design, I can't use any of their data. And I'm just like trying to get this thing published and get my PhD and get the hell out of here. So it's a great idea. It's a very valid question. 100% agree. But in practicality, you have to see that the study gets completed also, or then you're left with nothing. And the study blows up, your power goes to crap, and you're like, oh man, now I got to start over again. So you're always kind of, like you said, weighing these options of what's going to kind of incrementally move it forward. And then hopefully maybe you can come back, you can readjust things in future studies too.
Yeah. The favorite one of, let's call it, fitness people, I think we classify as that, but I think it's clear what I mean, is they're like, you should do it in trained people. I'm like, I would love to come to the lab. I'll take your biopsies. When are you coming?
Yeah.
You never hear of them ever again. So it's like I mentioned, like when I started out, I was exactly the same as everyone online now trying to read these studies. I was just fortunate that I could sneak my way into the field, but I have the same goals and I want to do the same studies they all want to do. I just unfortunately uh, run into the actual limitations, and it's no longer just, oh, this will be really cool. No, I know unfortunately what it takes to do it. It's not easy.
Yeah. The trained subject thing is, on one hand, yes, it's a great question because we obviously have some data showing that trained response is different. But anyone who's ever tried to recruit trained subjects, it's like, good luck. Like I've often joked, like I was at the University of Minnesota, and Cal Dietz is a good friend of mine. I've often joked with him that I'm like, okay, Cal, if I came over and said, give me 12 weeks of your top athletes, I'm going to have them do one protocol this and another protocol that, he'd be like, get the hell out of my gym. What the hell's wrong with you? Because his job is to take these athletes and to get the best results possible. His job isn't to help me complete my PhD research at potentially the detriment of messing with his athletes. So I get it. It's a good question, but it's so hard to get trained subjects, to get approval, what kind of study you're doing, how long is it? All those things just make it very difficult to do.
Yeah, honestly, that's just one of the many limitations of
Oh,
training.
there's so many.
Like by definition, they all have a different training state. Like untrained, everyone is more or
Yep.
less the same. So that already makes it more difficult. But then the one thing that most people don't seem to realize is, let's say you have two things you compare, two different types of protein, and one gives double the gains of another one. In untrained people, that double the gains is maybe 1 kilogram versus half a kilogram. In untrained people, that is like 100 grams versus
Yeah.
50 grams because they're no longer gaining. So even if something is twice as effective, you don't see it in trained people anyway. So there's so many limitations that people don't think of. It's like, of course, we want to do studies in trained people, but unless the government gives me money to do at least a year-long study, which they would never do because why would they? You're just not going to see any difference because everything progresses so slowly in them.
Yeah, I agree. And cost and money, and where are you getting these athletes and how are you messing with their training program? Like most high-level athletes are like, yeah, maybe a few non-invasive things, but no, I'm not doing your special secret squirrel research program for 12 weeks and have you stuff needles into my legs 6 times. That sounds horrible. I'm out.
And neither should they. Like they're professional athletes and
Yeah.
not guinea pigs. But so yeah, again, it comes down to we should try to do what we can, and we should hypothesize together with practitioners, other researchers, as much as we can. But this whole idea is like, oh, these researchers live in their own world. No, we don't. Like most of us started out the same as everyone else. We just ended up with a science job.
Yeah. So how'd you get the idea to look at 100 grams of protein in a single feeding? Because I think was the highest amount that I remember beforehand. I think Rob Boslab did something with 60 or 70 grams, and I remember the internet lost its mind at that point, and now 100 grams. Oh my God.
Yeah. Yeah, we might get back to the Bob Wolf study, but basically, so advice has been for quite a while that you need about 20 grams of high quality protein in a meal to maximize muscle protein synthesis, which is the process that drives muscle adaptations, which can be hypertrophy, but it can also simply be remodeling. And if you eat more, your body can't really use it, so you oxidize it, you burn it as a fuel. And that principle that has been replicated in various studies, including one of our own lab. So I've given a lot of talks where I basically said that advice. Oh, you need about 20 grams protein in a meal. But and that data is like the main argument for protein distribution. So how you distribute your protein throughout the day. So the idea there is that if you eat 100 grams in one meal, you can really only use about 20 grams of that, and most of it gets oxidized, basically wasted. So it's much more efficient to have about 20 grams, couple hours later, again have 20 grams, and then your total utilization of the protein is much higher. If you actually look at long-term studies who measure changes in muscle mass in response to different protein distribution patterns, most of them don't see a difference. Here and there, sometimes it looks like protein distribution maybe is a tiny bit better, but the effect is disappointing at best, if there's an effect. So that was one of the data points where it's like, these acute studies and these long-term studies don't seem to match. Now, my
In the
number one
long-term studies, was that dose equivalent, or was that looking at just frequency changes?
Yeah, usually they just give a certain amount of protein. So let's say 80 grams of protein in a day, which we would consider low, depends on the exact study. And then they gave it either in 3 meals or in 6 meals, or sometimes it is 3 meals, but there are 3 balanced meals or 1 meal with almost everything. Or the most extreme example, which really started me questioning this protein distribution hypothesis, was the intermittent fasting or time-restricted feeding data. More and more studies came out where if people ate, for example, all their food, including protein, in about 8 hours, which is horrible from a protein distribution point of view, they didn't lose more muscle mass than the control group, who had a much better protein distribution. And that is a very extreme. Like, I can imagine 4 or 5 meals, that might not be that big of a difference. But if you put everything in 1/3 of the day, like theoretically 2/3 of the day you're catabolic, if you don't see an effect of that, like, why are we even discussing 4 or 5 meals, right? If the extreme approach, if you don't see big changes there, I'm like, so that was one data point, probably the most convincing, where I'm like, I think maybe something in these acute studies might not add up. That's not true. Eventually, I came to that conclusion. In the beginning, I thought all these studies are just underpowered. It's a little bit what we just discussed, is if you just have a handful of subjects in a study and you measure them for 12 weeks, even if one group loses muscle mass twice as fast or gains it twice as fast as another group, you don't really see a clear trend. Okay, both groups stayed more or less the same, no significant difference. So I thought, we probably need 30 of these studies, and then we can combine the data in a meta-analysis, and then you'll start seeing that the protein distribution has an advantage. But as more and more data started coming in, the patterns started looking worse and worse. It just didn't really seem that protein distribution had any benefit at all. So that was the first point. I'm like, oh, maybe there's something wrong in these acute studies. So very quickly, my pet peeve is when people say, oh, these acute studies, they don't always translate to the long-term stuff. It's that exact phrasing, because someone has said it and other people are copying it, like word for word. Is always that exact.
And they don't even know what they're saying most of the time. It's just like something they just throw out at this point. Okay.
So the underlying logic, I'm not disagreeing with. But the point is, if you come to the conclusion that any two types of research don't add up, first of all, you don't know which one is wrong, because initially my reaction is it's probably the long term. It's not sensitive enough. You need much bigger subject numbers. If two types of research don't add up, the only logical conclusion is we're missing something. And until we figure that out, we have no clear understanding. So just saying, oh, the acute must be wrong is just so simple-minded, in my opinion. Anyway, it did seem that the results from those two lines of evidence were contrasting. Then, like, this is not a very convincing argument to me, but I found it interesting. If you look at some animal literature, most notably in snakes, they can eat like 25% of their body weight. So for a reasonable bodybuilder, that's like a meal of 20 to 25 kilograms. It's a decent meal. They can eat that, and they are just digesting the meals for 2 weeks, and protein synthesis stays elevated for 2 weeks. So I'm like, okay, at least somewhere in biology, there is the opportunity with large amounts of protein. Not everything gets oxidized, wasted. At least some animals have the capacity with one meal to just stay anabolic for very long. So then I went back to the acute studies. Have we tested that principle in humans? And the answer was really like, not really, because what usually happens with these studies is they do a study, usually exercise, and then they give different doses of protein. And then they measure muscle protein synthesis in all these dose response studies they were 4 to 6 hours in duration. And that seems pretty reasonable because typically after 4 to 6 hours, you have your next meal. So it seems reasonable. That's why I think it took a while before people, in this case me, tried something else. But is it really fair? Because if we go back to that snake example, he's digesting his meal for 2 weeks. Now, of course, we're not eating a 20-kilogram meal, but if you give a large amount of protein, are you sure that it's fully digested and absorbed in that 4 to 6 hours period? Because if it isn't even digested, then it cannot even reach your muscles. It cannot possibly be built into your muscles because it's still in your gut. And then the last piece of data was a long time ago. I remember it. I just woke up in the middle of the night and I had a meat burp. I just felt I was still digesting food. And I was like, that's true. I had a barbecue earlier in the day. And back then, especially, I was a bro. Protein, eat as much protein as I can. And I was like, holy moly, like this meal was like 10 hours ago, and I still feel I'm still digesting the food. So I basically put all those things together. And my hypothesis was if you consume a large amount of protein, the studies so far have not really seen the added value because the added value is not in the first 4 to 6 hours. It's mostly the hours after that, but no one has measured in that period. So that was the basic hypothesis.
Oh, that's great. And yeah, the acute versus chronic is always, it's one of those things where yes, it's a good question. I remember talking to Stu Phillips about this too. And his point is some of the data matches up, but people don't realize the cost of doing a chronic study, the amount of time that's involved. And you also have to justify, what are you going to study chronically? It's not like everyone has an unlimited budget and unlimited time just to pick things out of thin air. So yeah, we're going to look at acute response. And then, of course, the next question is that acute response, does that transfer to be a chronic study? But you have to start somewhere to have some data, to have some idea of what you're going to look at in the chronic studies. You can't just go out willy-nilly and just start doing chronic stuff all the time either.
That is terribly inefficient. And our lab does both. So it's not like we have preference for either. But like every method has its pros and its cons. So a simple example, I can give you 3 liters of water and it will have 0 impact on your muscle protein synthesis. But if I give it to you in a long-term study, you gain 3 kilograms of lean body mass. That's just because you're violating an assumption of your measurement tool, which is that hydration stays the same, right? So instead of saying, oh, this type of research or even observational or animal is completely useless, no, what are the strengths? What are the weaknesses? And again, unless you have a pretty good understanding of all lines of research, and if they don't add up, have a reasonable idea of maybe why, and then do a study to try to unite these fields, you're just a one-trick pony and you're like, oh, anything that doesn't fit my biases,
yeah.
It doesn't add up. Your job is to understand why, and just dismissing stuff that you don't like is the easiest thing, but it's just don't claim you're evidence-based. You're just like confirming biases-based.
Yeah, and that's what a lot of people do when they go to PubMed. I just want to find the 5 studies that agree with my little talking point. And the other part that's also hilarious is you get new research, you're actually literally doing the new research, and then you get a lot of the parrots who are like, I knew this was true all the time. This is what I've been saying for years. It's, bro, you haven't been saying that for years.
Yeah. Yeah, but even so, that one is funny to me because like this study, I had this hypothesis about 8 years ago, and then first I had to find the money, then I had to do this study, et cetera, et cetera. So just having an idea is worth nothing. Like it's nice that it's great if you are an athlete and you have an idea and you try it and it seems to work for you, that's good. But from a scientific point of view, unless you've shown it, it's just an hypothesis. So the saying, I knew it was true, is just, it doesn't help anyone, because for everyone who says, I knew a ketogenic diet is superior for fat loss, there's another person who says the exact opposite. So it's, from a scientific point of view, saying that it is just not worth a thing. And even if you're right, in science, we like to quantify. Okay, let's say that a ketogenic diet is better. How much benefit can the average person expect, et cetera, et cetera? Yeah, all I can say is good for you if you knew it. If your betting average is on, like what I would see with what I would like ideally, that those people, especially like if just a fitness fanatic says it in their enthusiasm, I'm fine. I really dislike when the, let's call it the fitness evidence-based influencer people say, like I've been saying,
Yeah.
this new study confirms it. I'm like, where is your blog post
Yeah,
with
show me the
my
evidence.
top 20 hypotheses? I want to see your betting average, because you can't
Yep.
throw out 50 hypotheses and then when one gets confirmed saying, I've been saying this all along, show me your betting average.
Yeah, no, I agree with that 100%. And then back to the Bob Wolf study, was the fact that you used 100 grams, was it just higher than what they did in that study? Or do you want to talk a little bit about, because I know
So
that study brings up all sorts of, I remember when I was at ISSN when that study was released and got to talk to some of the researchers on it. And
yeah.
it was crazy just to ask other pretty intelligent science people about their opinion of it. And it was like all across the board, from this is amazing to this is the stupidest study ever. And
Yeah, so I'll start with why we picked 100 grams. Remember that barbecue I said I was digesting in
mm-hmm.
the night? So we did a pilot, let's call it a study. I was just with our department. We had a barbecue. So me and another gym bro, we were just like, okay, how much protein can we eat without getting sick? Like, how much would a gym bro eat who's, oh, protein, awesome? How much would you eat? But not, oh, I'm trying to get the biggest possible number just to have a crazy number and brag online. Both of us like could comfortably eat 100 grams, although it was like a little bit more than not the average person would eat it. You need to be a little bit of a gym bro, ooh, protein.
Yeah.
So we
Put some effort into it.
yeah, so it's okay. 100 grams is like the practical upper limit of what anyone would eat. Can you eat higher? Yes, but that would be a very small percentage of the population. So that basically it's what it came down to. We wanted to see what's the practical upper limit. If we quickly go back to the Bob Wolf study, so he compared 40 grams versus 70 grams of protein. That study also seemed to suggest like, ooh, that old 20 grams of protein is not the optimal dose. I don't want to make this too boring, but there's some methodological issues in that paper, why those results are pretty much an artifact. I'm actually working on a paper with Professor Wolf
Oh,
discussing
cool.
that. But yeah, if you actually look at the study I've published now and his findings, they're like they seem to have the same message that 20 grams is not the same reason of, sorry, not the optimum, but the reasons are very different. In his work, it seems that whole body protein breakdown, so that's not specifically in muscle tissue, it can be breakdown in any tissue, that seems to go down with higher protein doses. If you look in my study, you basically see no impact on whole body protein breakdown with the protein. So it's completely different result, and that is because of the different methodology. So why did we see an advantage? Again, that is because the anabolic effect, so the higher protein synthesis, both on the whole body level as well as in the muscle, just last much, much, much longer. So he only measured for about 3.5 hours from the top of my mind. He would have seen a huge benefit of that 70 grams compared to that 40 grams, not on protein breakdown, but on protein synthesis if he measured longer. But in the end, luckily, the overall message is the same. And well, we're working on the methodological paper. So slowly the field will move in the right direction, I think.
Yeah. And talk a little bit about, we'll talk about breakdown first and then the protein synthesis. Just as a background, most people know that your body is constantly using some amino acids. There is some in the bloodstream, but most of it is going to come from muscle tissue. But you're also depositing back amino acids into all tissues all the time. And if you go, and you've been around the bodybuilding space for a long enough time, there's this, I wouldn't say a myth, but it's rather prevalent about all sorts of things making you very catabolic, from cortisol being horrible to different training methods to all these different things. What are your thoughts about the average gym rat? Is muscle protein breakdown something they need to be super worried about, or what are your kind of general thoughts on that?
The short answer is no, they don't have to worry about muscle protein breakdown. But of course, the interesting part is why.
Mm-hmm.
So it makes sense, right? If muscle protein synthesis is good, like building your muscles, and the breakdown part seems to be the exact opposite, so it must be bad. But the thing is, what protein breakdown does for the most part, it allows damaged proteins that's either can be from training, but also just from metabolism, from oxidative stress. You always will have damaged proteins to take those proteins, break them apart back into amino acids, and then rearrange them again in functional amino acids. So the way to think of protein breakdown is it allows constant renovation of your muscle. You always have healthy tissues because it's constantly being renewed. So protein breakdown, like there's a reason our biology created protein breakdown. It is to keep our tissues healthy. And you can't do this in humans. So of course, this is in animal work. But if you have knockout models where various components of muscle protein breakdown are basically removed, so the animal loses the genes for muscle protein breakdown, they become smaller and weaker and die earlier than normal mice. So that shows as a principle that protein breakdown is useful. So don't think of it as a bad bank account. Okay, you can think of it as a bank account. So yes, income, protein synthesis is great. That makes you richer. But spending money, is that bad? It depends. If you invest in something that in the long term, or if you invest in employees that can earn you more money, like it's an investment in the future. Protein breakdown is the same. You're removing your damaged proteins. That gives you the building blocks to build new functional proteins. More practical, training increases muscle protein breakdown a bit. Makes sense. There's more damage, so you need to break those apart, make new muscle tissue. Nutrition inhibits muscle protein breakdown, and the amount of nutrition you need for that is absolutely minimal. Like you need just a little bit of protein or a little bit of carbohydrates. Almost anything you'll eat will be enough of a signal for your body to have the maximal reduction in muscle protein breakdown that's possible. So even if you think whatever this dude is saying sounds bad to me, I'm still going to do everything I can to reduce muscle protein breakdown as much as you can. The answer is don't be fasted. That's all you can do. There's no special techniques to further reduce it. So even if you think it's a big issue, again, it's not. There's nothing you can do beyond not being fasted to reduce it.
Yeah, I always try to explain to people, thinking of things in terms of flux or flow, that you want turnover is a good thing, right? As long as you have at the end result is moving in the direction you want. There's some old studies with, I think it was knockout mice. So for a while, I was looking at insulin sensitivity and all this stuff and went down that rabbit hole of, hey, can we just do things to just not put fat in fat cells? Would that make people leaner? And they actually did a study of knockout in mice years ago, and they found that the mice did get leaner, but what happened was the amount of NAFLD and the amount of fat deposits in the liver killed them off like super early. Like their lifespan was cut by 50% or some crazy number. Because if you can't take the fat and you have an excess and you can't stick it in storage in a fat cell, it just backed all the way up in the liver and caused all sorts of issues.
Yeah.
So I just think you want more fat too, deposit it in the fat cell, but you want to oxidize and burn it off the back end. You want to break down some muscle tissue, but you want to make sure you have a building up of that tissue at the same time. It's not this sort of static thing where if you just stop the outflow, that everything's going to magically be happy.
Yeah, you can imagine, let's say that you don't break down your damaged protein. That's just like your muscle is growing. You're like, oh, this is awesome. But if 80% of your muscle is damaged proteins, that sounds like a recipe to have muscle tears and like real injuries. It sounds good, prevent protein breakdown, but it's just thought a little bit too simple.
And that leads into autophagy, which you guys actually measured some markers of autophagy, which autophagy feels like it's the new
Yeah.
It's also the boogeyman, but also the amazing saving grace of every longevity expert known to man. Do you want to talk a little bit about what it is and what you found in your study? And again, you're looking at some markers of autophagy.
Yeah, like you mentioned, especially in the bodybuilding world, protein breakdown was labeled as a bad thing because you want to have a net balance, a positive net balance into muscle, so it must be bad. In the longevity field in the last, I would say, 10 years, they have developed a little bit of a pretty much the exact opposite view.
Yeah.
Where the idea is, if you're always anabolic, that reduces longevity. And things like caloric restriction help you live longer. And then they were like, okay, that's not really practical. Can we trick the body into thinking that we're not always anabolic? And then the concept of time restricted feeding or intermittent fasting came up, where you still eat quite some bit in your feeding window. And then you have, for example, 16 hours where you don't eat anything. And during that fasted period, essentially your body is starving. So there will be higher protein breakdown, just as we discussed. As long as if you're not fasted, you've already did everything to inhibit protein breakdown, and autophagy is just a subclass of protein breakdown. But the idea is that if you can break down those damaged proteins, that's just healthy. So you want to prevent the accumulation of damaged proteins. Now, so muscle people just think about their muscle, but then other people think like Alzheimer's is basically the accumulation of misfolded proteins in the brain, for example. So the longevity field, all they want to do is make sure that damaged proteins don't accumulate. So they want to stimulate autophagy. And again, how do they do it? Either with very low caloric intake, so you're essentially starving, or with not eating for periods, so time-restricted feeding. So in this study, my hypothesis, because again, one of the reasons I did this study is like, these acute studies don't seem to align with intermittent fasting. Like they should be catabolic for 2/3 of the day because they're not eating for 16 hours of the day. But not eating 16 hours of the day is not the same as being fasted for 16 hours of the day. You're fasted when you've completely digested and absorbed your last meal. And my whole hypothesis was, with that 100 grams of protein, it's going to take forever until that meal is fully digested. So in this study, we actually found that with 100 grams of milk protein, at the end of 12 hours, which was how long we measured, the meal was still being digested. So this idea of we take the same amount of food, but we just eat it in a much smaller window, and then we're fasted in that other window, that is just not right. It just, your meal is being digested longer. So it doesn't really matter if that same amount of food you spaced out. Maybe it matters a little bit, but just the ideas of whenever I finished biting on my last bite, now I'm fasted, that's just completely wrong. And how long are you still in a postprandial state after your last bite? That depends entirely on how much you ate and characteristics of that meal. But yeah, one of the things we measured during our 12-hour period was a lot of anabolism stuff, but we also wanted to measure that autophagy. It was just a marker, but just a marker of autophagy. And what was really interesting is that with the 100 grams of protein, anabolism was sky high, like the highest values you can possibly get for 12 hours long. But the autophagy just, it didn't care at all. Like it was not that the 100 grams of protein, had no difference with 25 grams of protein or even no protein at all. This whole concept that anabolism and catabolism are like it's one or the other, and you either stimulate anabolism and you're dying faster, or vice versa, that seems a little bit too simplistic. Now, a few disclaimers. That marker is one of the weaker markers in the study. Perhaps even more important, we measured that in muscle tissue. That doesn't mean that's the most relevant one for the bros, of course, but that doesn't mean that let's call it the Alzheimer proteins are not accumulating in your brain. But at least
other
for
locations.
muscle, at least for For muscle tissue, it's not if one thing is on, if anabolism is on, then all things catabolism are off, and that it's a sliding scale. They seem to be regulated pretty independently.
Yeah, and people forget that if you look at how often most people eat, if autophagy was not working, my little air quotes here, we would know that we'd find all these people with like misfolded proteins, and it'd be like the garbage truck was never taken out of your body, right? It doesn't add up. Again, you can argue about what rate is it accelerated or not accelerated, but as like exercise is one of the main things that'll massively upgrade autophagy. And again, in which tissue, to what degree, what marker are you using? It gets messy real fast. It's not as simple as, well, bro, if you don't eat, autophagy is better. It's like,
Yeah. And like, I certainly don't want to put out the message that it's not relevant at all. I just want to give a different perspective
yeah,
because, again, so far the communication is mostly ooh, be careful if you're like, I quite regularly get emails like, hey, is there a drawback of eating too much protein? Because if you're always anabolic, then blah, 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 autophagy, bad stuff.
yeah,
And
right?
that at least, like, I'm not saying it's not the case. Again, we only measured something in
Yeah.
muscle tissue, but it's definitely not as clear cut as the people who push the time restricted agenda are making it out to be.
Yeah, and we'll link to a podcast I did with my buddy Dr. Kurt, who did his PhD on autophagy. And yeah, it took us like an hour and 20 minutes to basically say, what we know is maybe not true. And yeah, there's a whole bunch of unknowns. Which is, that's the process of science.
Yeah, my study is challenging a lot of views in my field, and I'm sure in that field, views will like that field is so young that will continue to develop, and who knows where it turns out.
Yeah. So two questions. On the anabolic side, you saw like probably one of the most robust and probably highest, is it the highest response? I don't know of a response that was higher that I've seen. And then
Yeah,
the follow-up
so
question, is that related to the protein source that you tested?
it's a little bit difficult how to quantify how high it is because the way muscle protein synthesis is measured, it's very sensitive based on which amino acid tracer do you use. So I used multiple amino acid
Yeah, I
tracers.
think he's like up to 4, I think, wasn't it?
Yeah, in total, we used 4 tracers that we applied, and I think we used only 2 for the muscle protein synthesis, and the other one have other use cases. But basically, what we wanted is not that people say, "Oh, you saw with that amino acid. Are you
Right.
sure that applies to other one?" We had different amino acids, and there's so many ways to measure muscle protein synthesis. We did them all. Okay, see the pattern is, but that makes it difficult to compare to
Other
other
methods.
data because, for example, if you measure over a 4 hour period, that was my first 2 biopsies were immediately after exercise and then before protein ingestion and then 4 hours later. You can't really compare that to someone else who measured in the first 2 hours, for example. So generally I advise to not directly compare literature values, but if you just look at the patterns in the data, the patterns are smashing. The percentage increases compared to placebo were pretty much off the chart in the study.
So do you think, and before I forget, and remind the listeners, what type of protein you used in the study? And if you used a different type of protein, if you used a whey protein, do you think you would see anything different? Which again is kind of speculation at this point.
Yeah, so we used milk protein for various reasons. So one is that you already alluded to. We used a very fancy method where tracers go into the protein, very expensive to produce. The ideal way to do that is with a cow, it just has the highest efficiency. And then with that milk, you could separate it in different types of protein. For example, the fast digesting whey protein that most people can know, or the slow digesting casein protein. But then you're left with less total product. And we needed all the protein to give as many people 100 grams of protein as possible. So that's one of the reasons why we took milk, just the most cost-effective approach. But a more important reason is that in the Western world, milk protein has the largest contribution to protein intake. So I knew, like, this is a question that everyone should always ask, but I knew this question would be asked, does this translate to other protein
Yeah.
sources? I'm like, I don't know. Other proteins should ask the question, does this translate to milk protein? Because milk protein is the largest contribution. Nevertheless, the question is is it still a weird exception? Yes or no? And then I've seen the comment like, ooh, milk protein is 80% casein. That's slowly digestible. So milk protein is quite slowly digestible. Does that reflect other proteins? Depends. Yes, milk and casein protein are slowly digestible, and that does not reflect most isolated proteins like whey protein or a soy protein powder. But most people don't eat that. Most people eat mixed whole food meals. Of all the isolated powders that you could use, we used one that most reflects mixed meals. So yeah, I don't think we could have picked, not to pat myself on the back too much, but I don't think we could have picked a more relevant protein source as the largest contribution and the one that most resembles mixed meals. Now, maybe your question is like, why didn't you pick mixed meals? But that becomes very complicated
Oof.
with what's the intake, what's the impact of the different caloric balance? How are you going to compare that between groups? Here, we really wanted to show that protein on its own can keep you anabolic for many hours.
Yeah, and I believe that the protein you use, you actually put the tracers in the feed, which is given to the cow, which then produces the milk protein, which then has to be isolated, which then has to be given to humans, correct?
Yeah, it's almost correct. So we don't put it in their food, although you could do that. We
Oh,
don't
okay.
actually infuse it in the cows,
Oh, it's an
just,
infusion. Okay, gotcha.
just because it's slightly more efficient.
Sure.
Uh, but so just so that people understand, we have this, let's call it it's just a regular amino acid. The only functional difference is that it has like a chemical flag that has
A little
no
label on
effect
it.
on your physiology, but because of that flag, we can follow it throughout the body. So I have here the bottle of this stuff. Then I infuse it in a cow, and I don't think people realize cows are gigantic. So I have this little bottle of stuff. I infuse it in this enormous cow. Only the amount that ends up in the milk, because the cow is going to use that amino acid. It's going to use it for its muscle, for its brain,
Mm-hmm.
for its liver, for everything. Only the part that gets in the milk is or net yield, like everything else is essentially lost. Then from that milk, we make protein supplements. We give that to the human. That has to be digested. Not everything is digested, of course, has to be absorbed, goes through the circulation, and then ends up in the muscle. And then we take like a minuscule amount of muscle, and there we can measure how much of that initial thing end up. So that thing has made like this whole weird trip around the world. And then we're like, it's almost, I don't know, if you throw a handful of sand on a beach and then 2 weeks later, you're like, okay, Mike, can you count how many salt there is on this beach? Like, it's so absurd how sensitive the technology is.
And do you know about like for that 100 gram per dose, like per subject, do you know about how much that cost is?
Ooh,
I'm just curious because it's got to be expensive.
it's the, I think so it really depends on, you can't say like label protein costs this much, but my guess is that this would be somewhere, my guess would be somewhere $50 to $200 in just in raw materials, like the
Mm-hmm.
tracer amount, which is not that much, but you have to infuse a cow, which you have to buy like ethically. You need veterinary doctors. You have to infuse a
Approval.
cow
Yep.
for a lot of days, so you have to hire a barn. So everything combined, it's like hundred thousands to do a study just to produce the labeled protein. So the raw ingredients are not that expensive, but it's so difficult because everything has to be approved for first for animal research, then for human and pharmacy cost. And so it's 20 different types of costs together. But just alone a trace, no, I don't. So the amount of tracer we infuse during a study like this is about, with inflation, probably like $300. So I would say it's probably like $400 how much we put in the protein. But again, that's just one of the costs, because you're infusing this cow and it has to be supervised day and night, because if the cow lays down and he closes his vein, then the tracer is just
Yeah, just
everywhere. Too many man hours, and you always need like an animal doctor. I don't know the proper word for it. So just the complexity is absurd.
Yeah. And I think that's the one thing that, because you read the study, and if you don't know the background, it's a very short thing in the study, which makes sense because you got you did everything tested known to man in this thing. And people gloss over that. And then you see comments online of, you dumb nuts, why didn't you test whey? You have no idea what you're even asking. And I think your lab did a study overnight in humans looking at, I think, a 40-gram whey dose also. And if I correct my memory, I don't think you saw too much of a difference compared to the earlier casein work in a different studies.
Yeah, so it's interesting because some people are like, this guy doesn't believe in protein distribution, rah, rah, rah. And I'm like, wait, before everyone thought I was like the protein distribution guy because I did several studies on pre-sleep protein.
Yeah. Yeah. Yeah.
So before it was everyone's, oh, you just have your agenda and blah, blah, blah. So it's funny that now the other camp
Yeah.
attacks me. But so yes, we did. So like you mentioned earlier, or we did a bunch of studies with casein prior to sleep, for the most part, just for practical reasons, aka money. But we always got the question, does it have to be this slowly digestible casein? Or can it be whey, for example? So there, pre-sleep, I would make the argument that maybe casein, well, it's interesting. So the idea is it's a slowly digestible protein, so it sustains amino acid release during the whole night, because that concept that we discussed earlier, like usually you eat after 4 to 6 hours. After dinner, let's say 6 o'clock, it can easily be 10 hours or longer that you don't eat. So pre-sleep protein makes sense. And even when you take something pre-sleep, a fast digestible protein might still not, like it might provide a lot of amino acids in the first half of the night, but not the second half of the night. And then the hardcore bodybuilders are, and that's why I wake up and
Yeah,
slam
wake up at 3 in the morning. I did that for a while. It didn't help. I just got fat and my sleep was atrocious because I couldn't get back to sleep.
Yeah. Ironically, like sleep is like one of the most anabolic things you can do. So as much as I love protein, I would recommend just sleeping and getting your protein in before. But we always got that question of, does it have to be casein? Because we know that works from the studies. So we decided to compare the casein versus the whey. And both were effective. Let's start there. But the whey seemed to be slightly more effective. It was not sick. There was no significant difference. But if you just looked at the bar graph, so to speak, the whey was slightly higher than the casein, which is interesting because by now quite some studies have compared whey versus casein. But most of those studies have always used like that 20-gram dose.
Right.
That's often recommended early in the day. So for a long time, the hypothesis was like, at least early in the day, when you know your next meal is going to be in 4 or 5 hours, it makes more sense to get like a high amino acid availability with a fast digestible protein. And it doesn't matter that it won't last that long because you're going to have your next meal anyway. So that's why they used like that 20-gram dose there. But pre-sleep, we used a bigger dose because, again, the goal was to last the subjects during a longer overnight period. So that's why we used 45 grams of protein. But even the whey protein, I believe it was still elevated from the top of my head. So after 6 hours, it was still slightly elevated above baseline. And only literally when the subjects woke up, that's when it was completely back to baseline. So even with a fast digestible protein like whey, that the more you eat, it will also take longer before it's fully digested and absorbed. But of course, there, the casein wasn't fully digested and absorbed even after 7.5 hours of sleep. So it looked that the whey protein was slightly higher than casein, which is, if you look in the literature, a pretty consistent finding. Usually there's no difference or whey is slightly higher. But here the situation is very different, longer measurement period and higher doses. So if there is a situation where a slow digestible protein would shine, this was it. But still the whey seemed a little bit higher. Now I've said seemed a little bit higher like 5 times now. Honestly, I think they would be exactly the same because, as I mentioned, the casein was still digesting. So I think the next hour, the casein would have catched up
Sure.
to the whey. The counter argument is there. Who cares? Because you're now awake and you have your next.
Right. You can go eat.
just to think of the principle. But to make it short, in practice, both are two very high quality protein sources, and take whichever one is either cheapest or most feasible or your preference, that is way more important than any minor difference between those two protein sources.
Yeah. As we get close to the end, a couple more questions. Do you think you'll see now I haven't looked, someone probably already did this, the mega anabolic protein program 4000, where it's 3 doses of 100 grams of protein a day or something, right? They're just over extrapolating the research and going, well, if you could get, almost like, was it, I think 13 grams, I think, just showed it was potentially incorporated into the muscle tissue from a 100-gram dose. You can do that 3 times a day, then you'll, triple your effects.
Yeah, I have no clue what people will do. So if you read the paper, I don't know if I regret it, but you could say that the title it really sounds like I'm pushing more protein will result in more gains. That is,
Right.
if you just read the title.
And these are people who only read the title and barely read the
you
abstract.
Walk away with it. Now, I would counter that by saying I have by far the longest limitation section anyone has ever written in a protein metabolism paper. So if someone says like your title isn't over this, I'm like, I think I more than balanced that with the longest limitation section ever. Moreover, if you read the paper, I nowhere say this study means that you should eat this much per meal or in total in a day. I completely avoid saying how much protein should be measured. I treat this study as what's called a proof of concept study, that if you eat more protein, anabolism stays elevated for much longer. And that kind of takes away the main argument, the main data we had in support of protein distribution. So the message I'm throwing out there is, if you absolutely want to do everything possible for muscle mass gains or just general recovery, well, there's really only upside for more protein, and there's really only upside to also trying to distribute it throughout the day. So by all means, I'm not saying to not do that. All I'm saying is probably protein distribution doesn't matter as much as we thought, at least if protein intake is high enough. So with one large meal, you can cover at least half of your day, as this study showed. That's really the only practical recommendation, that please don't spike your cortisol because you haven't had your next meal in 4 hours. That's the only thing I'm suggesting. I'm not suggesting eat 100 grams of protein every this many hours.
Yeah, it reminds me, even before this study came out, I was at ISSN. We may have been at the bar there talking to Dr. David Church and Dr. Dan Moore, and it was just fascinating because they were going back and forth about, does meal frequency with protein even matter? And their kind of conclusion at the end of it was, maybe, but if you're getting all your protein in, like, it's so far distant down that if you're just getting enough protein in, they both agreed that's like by far and away like the number one thing. And then you can start splitting hairs after that too. So I think that sometimes people miss the forest for the trees. And if you're getting adequate amounts of protein, my interpretation of this study, correct me if I'm wrong, is you could maybe have 100 grams in the morning. You could maybe have more later, but you're still getting a fair amount of protein during the day, and you're probably going to be pretty good. You don't need to be super worried of, oh, it's 3.5 hours and I need exactly 21.5 grams of fast acting whey protein, or all my muscle is going to fall off. Your body's much more robust than that.
Yeah, that's exactly the takeaway. And in practice, if you prepare an athlete for, let's say, a bodybuilding show, I'm not gonna come up with a meal plan with 100 grams of protein at breakfast. Like, it's possible, but it's not necessarily what should be recommended. And people just, I don't know, at least some people are so offended. Oh, I ate this way. This study suggests this is also possible. They're saying what I'm doing is wrong. I'm just saying, no, it doesn't have to be that strict, most likely. And who knows, maybe you're lucky and this gave you a 4% advantage. Good for you. It's more a message for the people who don't want to have their timer every 4 hours to slam a shake.
Yeah, that's my big takeaway I took, is that I think it allows us much more flexibility to look at protein. And hey, if you've got, so I'm thinking of like professionals and even some military people and our docs and people I work with, this gives me a little bit more research to say, Yeah, if you're going to go do an 8-hour surgery and it's first thing and during the day and you only have time for one meal beforehand, yeah, let's bump up as much protein as we can in that meal, and you're probably going to be fine because would you expect the surgeon to step out in the middle of the surgery to go get their protein? Like some professions and some things, it's just unrealistic. So now we have some cool data to show that, yeah, you're probably fine. Just get in more protein. You're probably going to be okay.
Yep.
Awesome. Very last question. Like knowing all the work you've done on protein, especially with all the other studies and everything else you've done, for people listening, if they were only going to listen to like just the last couple of minutes, what would be your top 4 takeaways regarding protein?
The first one is, if you just want to exist, you really don't need that much protein. So there's a lot of commentary on the recommended daily allowance and that it's way too little. No, it's fine if your goal is to just not lose protein mass as a normal individual. So you really need little protein to just exist.
Yeah,
Now,
just stay upright.
exactly. Now, I think there's a lot of people, especially if they're listening to this podcast, who want to either optimize their health and or their physical performance. There is a reasonable amount of evidence that more protein is better. Probably most of your listeners are into fitness. There, generally, the recommendation that is given is 1.6 gram per kilogram per day. Based on the meta-analysis that you could also have some criticism, but it is a pretty good estimate. So it's essentially double the RDA. If you do that, you probably have at least 90% of all the protein details covered, because again, the more protein you eat in general, the less protein distribution matters. But also, the more protein you eat, the less protein quality. We haven't touched on it that much, a little bit in the whey versus casein discussion. But ultimately, what does protein do? It gives different amino acids to your body that are used as building blocks. Even if your protein is slightly less efficient, so for example, plant protein, as long as you eat enough, like it's the sum of amount times quality, you still end up with enough. So even vegans, maybe they need a little bit more. So my main tips is, number one, if you just want to exist, 0.8 gram per kilogram per day is more than enough. If you're an athlete who wants to do like the minimal amount of effort, just try to eat a little bit more protein. And with 1.6 gram per kilogram per day, you should have 90% of your goals or your maximum gains covered. Maybe if you're a vegan, go a little bit higher just to play it safe. That's about it. If you're a competitive bodybuilder, I would still optimize protein distribution, maybe just from a satiety and practical point of view, but no one really has to worry about it if they eat enough.
Awesome. I think the big takeaway is making sure you get enough protein, higher amounts, probably better. And if you do that, you're going to be pretty good most of the time.
Yeah, I'm joking in the lab that after this study, we're done. We're getting no more funding. We figured it all out. Just eat more protein. Everything else is details.
Awesome. And where can people find more about you? I don't know if you have any public facing stuff now, or you're going to crawl back into the lab and do another cool study and we'll see you in 4 years again, or
I was also joking in the lab, like literally, I don't know if I'll be ever as motivated to do studies again, but you only get more and more crazy ideas. But
yeah,
I'm
that's
trying to
good.
balance. I'm trying to balance it again, because at the end of the day, me reading studies from especially Stu Phillips' lab back then, that's what got me into science.
Yeah.
And now it's my turn to hopefully inspire one or two new people who come up with smarter stuff than me. So people can follow me on most social media as Nutrition Tactics. Used to be very active, slightly less active in the last couple of years because this study sucked up every waking moment. But I'm back. This is the first podcast in a while, and I'm not stopping. So I hope to see people at Nutrition Tactics.
Yeah, and you've got a lot of great stuff there that's actual. It's nice because it's research based, but to me, it's also very practical. Like you do a good job of saying, okay, here's what the research showed, and here's the pros of it, here's the cons, and here's the actual shocker, like context of why this study matters. Where I think a lot of times the context and the details just get thrown out, and it's just a weird headline that may or may not be true. So I appreciate all the great stuff, and Thank you so much for doing the study and all the work that went into it, especially congratulations on the publication in Cell, which is a huge top tier journal. And it's so easy for me just to sit on my couch and read something like this and have a little bit of an idea of, holy crap, this is a piss ton of work that went into this. And I just get to sit here and drink coffee and read it. So that's great.
Thanks so much for the kind words. And let's see if we can do another one within 4 years this time.
Yeah, sounds good. Thank you so much. Really appreciate it.
I see you, Mike.
Thank you so much for listening to the podcast here. Huge thanks to Dr. Jorn Trommelin for being on the podcast. Really appreciate it. A huge thanks to him in his lab there with Dr. Luc Van Loon and everyone on that study for all the work that went into it. It was a massive study that they measured a ton of stuff in humans using tracers, looking at protein, which is something all of us are very interested in for adding more muscle and improving body composition. So huge thanks to him and for giving up his time to chat with us here. Really appreciate it. If you want to learn his top 4 takeaways regarding protein, go to MikeTNelson.com/flex4. That's MikeTNelson.com/FLEX and then the number 4, and you will be able to get those. And then also we've got the Flex Diet Metabolism Summit coming up February 9th through the 11th. Make sure to sign up for that. You can get free access to 30 plus talks that I have custom picked all of the speakers there. It's going to be a lot of fun and it's free. You just have to sign up with your newsletter, or I should say you'll be on the newsletter, but you'll get free access to all of the talks for the weekend of February 9th through the 11th, 2024. Go to flexdietsummit.com. And then if you want something very tasty for electrolytes, check out LMNT. Go to drinklmnt.com/Mike Nelson. Thank you so much for listening to the podcast. I really appreciate it. If you enjoyed this episode with Jorn, please share it around and tag me on the socials so I can say thank you. Any stars you feel is appropriate helps. Even a very short review in the old iTunes helps us a ton to move up in the rankings. Thank you so much. Really appreciate it. Talk to all of you next week.
What do you suppose they call that? A novelty act?
I don't know, but it wasn't too bad.
Well, that's a novelty.
This podcast is for informational purposes only. The podcast is not intended as a substitute for professional medical advice, diagnosis, or treatment. You should not use the information on the podcast for diagnosing or treating a health problem or disease or prescribing any medication or other treatment. Always seek the advice of your physician or other qualified health provider before taking any medication or nutritional supplement, and with any questions you may have regarding a medical condition. Never disregard professional medical advice or delay in seeking it because of something you have heard on this or any other podcast. Reliance on the podcast is solely at your own risk. Information provided on the podcast does not create a doctor-patient relationship between you and any of the health professionals affiliated with our podcast. Information and statements regarding dietary supplements are not intended to diagnose, treat, cure, or prevent any disease. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to therein. If you think you have a medical problem, consult a licensed physician.